But in question 4a, let's just read the question. A student has built an aquarium in their school lab and wants to provide nutritious food to the fish. They've bought a can of dried brine shrimp cysts and want to hatch these organisms in the lab. The student wants to investigate the effect of changing the temperature of the water and the number of brine shrimp that hatch after 24 hours. So let's just look at this. So this is the apparatus that they're using. This is the equipment that they've set up. This is state a research question for this investigation. So to formulate a research question, let's just look at this again. Let's just look at what the student wants to investigate. They want to investigate the effect of changing the temperature of the water, the number of brine shrimps that hatch after 24 hours. So in a research question, we have to just rephrase this basically. So the research question can always, it should always start with how, by the way. So we have to just write, how can changing the temperature of the water affect the number of brine shrimp that hatch? That is a research question. Alright. A research question can be, let's just write it down. Let me just teach you how to formulate this for research. So the research question should always start with a how. So how can increasing the temperature of the water affect the number of brine shrimp that hatch? Question mark. That's a research question. That's done. That's it for this question. To just we have to just formulate a research question. We have to just paraphrase whatever was there and whatever they want to investigate, just frame it with the how. And that's it for the research question, and that's it for this question. Now let's look at question 4b. Identify the independent and dependent variables in this investigation. So in this investigation, we're basically trying to understand how changing the water temperature will affect the number of brine shrimps that hatch. So independent variable is always going to be the variable that we're going to change. So by changing the water temperature over here, so the independent variable is going to be the water temperature, and then a dependent variable is a variable that is getting affected, and the variable that we're testing for, the variable that we're going to see, the variable that is affected by the independent variable is basically a dependent variable. So the dependent variable is going to be the brine shrimp cysts. We're checking how many hatch at different temperatures. That's it for this question. Now let's move on to question 4c. It asks us the two variables that the student must control. So the control variable 1, the control variable 2. Let's just think. So one control variable that we might need in this experiment, I think it will probably be the volume of water, because different volumes of water may affect the final outcomes, and it may affect the overall temperature as well. So let's just write the volume of water. Let's specify the unit as well. You can centimeter cube. Don't know how to do it in this one, but in the software you get an option. This option right over here, you can just click on it and it'll let it as a power. Then we have control variable 2, which is gonna be, let's just write the pH of water, because the water has different pH. If it has a slightly acidic or alkaline pH, then obviously it's going to affect the results. So we can write the pH of water as well. pH of water 7 has to be neutral. Now let us go ahead with question 4D. Let's just read out the question for a reference. The information on the label of the can of the cyst suggests that the temperature must be in the range of 22 degrees Celsius to 30 degrees Celsius. As we can see here, we see that they've given a temperature range that we have to keep the brine cysts in. So let's just move on to the question and see what they're asking. Use scientific reasoning to explain what would happen if the student did not use the recommended temperature range. Now let's just think about this. Um, let's break it down. First things first, they've said that the temperature range is it's between 22 degrees to 30 degrees. So this is the optimal range of which in which we have to store the brine shrimp in. But if we were not to store it, then let's think of what might happen. For instance, let's take a hypothetical scenario. Let's say that we store it in 19 degrees Celsius, which is way below the temperature range. So what might happen? If we store it in 90 degrees Celsius, obviously the brine shrimps they won't hatch properly. They will not develop and they won't hatch. So that can be one point. Let's just write if my bad, the student used a temperature that is below the 22 Celsius range, then the brine shrimps will not hatch properly. Now let's think of why they wouldn't hatch properly. The brine shrimps, it's brine. The brine shrimps wouldn't hatch properly because their enzymes would the enzymes would denature, because the enzymatic activity, it's not in the peak anymore. It's going down. So let's just write this is because the enzymatic activity will denature. Now moving on to the second point, as this is a 4 marker, let's just write the other case scenario, which is what would happen if they took a temperature range that is higher than 22 to 30 degrees. Now let's move on to question 4D. Let's just read the question for our reference. Let's go ahead with it. The information on the label of the can of the cyst suggests that the temperature must be in the range of 22 degrees Celsius to 30 degrees Celsius. So as we can see here, we see that they've given a temperature range that we're supposed to store the dried brine shrimp cysts in. Now let's just look at the question and see what they're asking for. Use scientific reasoning to explain what would happen if the student did not use the recommended temperature range. So let's just break this question down. So it is basically asking us what would happen if the student did not, if they did not stay in the given temperature range. So there are two scenarios for this. One is where they take a temperature that is below the range, and one is where they take a temperature that is way above the range. So let's just take a hypothetical scenario where the student uses a temperature range that is way under the given range. Let's say it takes 18 degrees Celsius. Now let's think what would happen if he did not like what would happen if he was below the range. So first things first, obviously the brine ships would not hatch because the reaction rates they wouldn't be that efficient. And when you're way under the temperature range, the reaction rate it won't be efficient. The enzymatic activity also won't be efficient. So let's just write the first point. If the student were to take a temperature that is below the given range, then the enzymatic activity will decrease. Now, as this is a 4 marker, we have to write our point and then write what happens to the brainstem cyst. This will cause the brainsstems to not hatch or die. They're gonna die. that is that is just like a bombshell, but they're gonna die. Similarly, let's just write the vice versa of this. I mean, not the vice versa, but the opposite of this. What would happen if they took a higher temperature? If they took a temperature that is higher. So let's just write that. The student were to take a temperature that is higher than the given range, then the enzymes will begin to denature. So whenever you take higher temperature ranges, whenever they're way high, the enzyme activity will start to denature. Because when you reach the optimal point, they will work properly. But when you go way above your limits, it's gonna denature. For example, if you take 40 degrees, let's say, it's way over the 30-degree limit. So the enzyme activity it will slowly start to denature because they're not set to work in that they do not work efficiently in that environment. So the enzymes will begin to denature, and then similarly, if the enzymes begin to denature, then obviously once again the shrimps are gonna die. Let's just write that. This will result in the brine shrimp cysts not hatching, ultimately in death. Boom, that's our answer for this one. 2 points for each because it's a 4 marker. 2 points for each scenario. Right done. That's it. That's it for this question. Now let's look at question 4e. The student performed one trial. He added 0.5 grams of brine shrimp cysts to 100 centimeter cube of water at different temperatures. After 24 hours, the student took one drop of water, 0.005 centimeter cube, and observed it through the lens of the microscope. The student recorded their data on the page in their laboratory notebook. Now let's move on to the next page and see what they're asking. my bad. Let's just look at this. So over here we see they have a notebook kind of thing. It's very rough. They did not structure it properly. I think you have to look out for that because they might ask us to graph it properly in the next question, which they will, I know. But spoiler alert. Let's just look at the values. At 25, which is this, let's just fill this up. Let's see how many hatched. 1, 2, 3, 4, 5, 6. 6 cysts hatched after at 25 degrees. So let's just keep that in mind. And now let's just move on to the next. Present the student's data in a table and use the image above to determine the missing value. See, I'm an expert at foreshadowing. Let's just make a table. Okay guys, we're back. I'm done with the table. This is how it should look like. Let's format it properly. And to determine the missing value, I think we just counted the brine shrimps. That's it. Now we have question 4F with us, so let's just read it for our reference. It's the first numerical question in a very long time, so I think we'll have fun with this one. The data in part E is for a sample of 0.05 centimeter cube of water. Use this data to calculate the total number of cysts that hatched in 100 centimeter cube at 30 degrees Celsius. So, this is a really simple question. We have to just find out how many cysts will hatch at 100 centimeter cube. So, we know that they're asking us the value at 30 degrees Celsius. So, if we just go back to the old questions and look, it's six cysts hatched at 30 degrees Celsius. So let's just move over here and let's just think. So we know that six cysts hatched. So we're just gonna multiply that with 100. It's gonna be 6 into 100. We're gonna divide this by 0.05, because first we're finding out how many might hatch in, let's say, how many might hatch in 100 centimeter cube, and then we're going to divide this by 0.05 to find the total number, to see how many cysts will actually hatch. So if we do this, we're going to get 12,000. Yep, so 12,000 branches, 12,000 branch cysts are going to hatch out of this. So that's our answer for this. It's going to be 6 into 100 by 0.05. So that's how we solve this question. If you put this in a calculator, you'll get the same answer. That's it. That's it for this question. Now we have question 4G. I'll just save you the time and I'll tell you what the question is asking. I'll just get to the point. So the question is basically a suggest question where they're asking us for a safety precaution which the student should take while he's performing his investigation, and we have to justify it. So we have to just give one precaution and we have to write why it's needed. So let's just look at the investigation. Let's see what he's using for the investigation. We see he's using a microscope. And if we go back, what else is he using? Yeah, this is his setup. So we see there's electricity involved here. There are some plugs involved. So first things first, there's electricity. And it's a problem if we get electricity and water into contact with each other, because he is using water he's just putting the shrimps in the water and seeing how they'll hatch at different temperatures. So to just make sure that the student does not get electricity and water into contact. Ensure that the student does not get electricity and water into contact. Just make sure this is there, and then the justification for this would be this will ensure that the student does not get electrocuted. This is the answer for this. Boom, safety precaution. There might be other safety precautions which you think are right, so you can just list them down as well. Now let's do question 4H, which is again a 2 marker to state one weakness and then suggest one improvement. So let's just think of some weaknesses that this particular experiment has. So if we go back and if we look at the table or whatever they made, we see that they've only taken one trial. They do not have multiple trials. So this limits them from actually getting accurate and reliable results, because some of them might be anomalized. They might not be the correct values that we're looking for. So you only get that if you take multiple trials, and if you make an average out of it, you'll get the value that is most close to the real result. So that is one weakness that this method has. Does not have repetitive trials. Let's just write weakness. This is only one only one trial. Then for our improvement, just write conduct repetitive trials, and that's it. Simple as that. You can just conduct repetitive trials. Let's just write at least these 3 trials, and then we're done with our answer. Boom, that's it. Now we have question 4I, which is an ethical concern question. So I think we can delve deep into this question, and we can think of what the ethical concerns might be. So first thing is that whenever we're subjecting these brain streams to an experiment, what happens is that, like, to find out the results and to find out what actually happens, we have to go to the extreme sometimes, and then that might actually cause them a lot of stress. It might cause them a lot of stress, and then they're living organisms, right? So we have to experiment in certain limits. So once we cross that limits, there's no bringing them back, and it will result in death, because we're playing with the life of many species over here. For example, if we took 40 degrees Celsius, 50 degrees Celsius, and just checked what would happen to them, obviously these species, they would not survive properly, because they would die. And then, like, we are ruining we're ruining an organism's chance at life. We're just experimenting like it's a plaything for us. So that's an ethical concern. And then subjecting it to stress, and the organism, they're not in their natural habitat, right? These things, they're supposed to be living in water, and they're supposed to be hatching like they do in the natural habitat. But no, we're doing this in a laboratory setting where the shrimps don't even know if they live even after they hatch. So that is an ethical concern as well. We can just write any of these. So let me just write an ethical concern would be that the brine shrimps are living organisms, and they should be experimented on. They should be experimented taking into consideration their limit and taking safe temperature values to ensure that they aren't subjected to extreme temperatures. We can go with this one. One ethical concern would be this.